Alright, this is calculus integrals, and we're going to be talking about definite integrals, and this is the third video. So, first of all, let's just set up what we did for antiderivatives back in the derivatives section. So that's going to be BA is going to be f of x dx equals FB minus FA. Okay? Now, B, realize that this is just going to equal some function. You're going to have two lines here, B and A. So just realize that that's this, and what we're looking for is the area underneath the curve. Okay. X, Y. Great. So let's just run through some examples. Examples are always good. Example. Let's just say that we have the integral between, let's say, 4 and 2. That is 2 dx. Well, remember, we have a constant property, right? So it's just going to be C, which is 2, times B minus A, which is 4 minus 2. 4 minus 2 equals 2. 2 times 2 equals 4. That's our solution. Now, let's go on to the next one. Once again, we're going to do it between 4 and 2. We're going to start 3x dx. Okay, well, remember what we did with the antiderivatives. First of all, we take the constant out, 3, right? Then we look at this function. It's going to be x. Now, it is already to the power of 1. And what we're going to do is we're going to add 1, and then we're going to take that whole exponent and divide the whole value by it, 1 plus 1, okay? So now, what you should have is 3 over 2 x squared. And that's our solution. Now, that's actually the function of the solution. You caught me. I need to do it between 4 and 2, right? So actually, the correct solution would be 3 over 2 times 4 squared minus 3 over 2, 2 squared. Okay? So, that's 16 divided by 2 times 3 minus 3 over 2 times 2. Everything turns out to equal 3. Very good. Let's shift on over. We can go to something a little bit more cool looking. Between 3 and 1. Okay? X squared minus 1 dx. Oh, plus 1 dx. Okay? Well, let's just split them apart like we did before. That's the same thing as 3 to 1 x squared, right? Plus 3 to 1, 1. Both of them have their own dx. So now we can just solve for it directly. We know the way of doing this. All you do is you take the same rule. It's already to the power of 2. You add 1. You divide the whole quantity by that exponent. Then you evaluate it between 3 and 1. You add the same result over here. Essentially 1 times 3 minus 1, which is just going to be 2, right? Because it's not even dependent on it. So your solution will be 3 to the third power divided by 3. 3 to the third power is 27. Divided by 3 is going to be not 27, but 9. Here, just so that you guys can follow me, I'm going to just say 1 divided by 3 x to the third power plus 2. Okay? Now, I'm going to evaluate this 3 to 1. Okay? So, this equals 9 plus 2. That's the 3. That's to plug in the 3. Minus essentially 1/3 plus 2. And I can let you guys do the math if you want, but I mean, in the end, it turns out to equal 32/3, if I did that correctly. Not sure if I did, but you get the concept. Let's see. How about we run through one more example? I would say between pi and 0. Let's do the integral of cosine theta d theta, okay? And what we're going to do is we're going to do the antiderivative again, right? Which I'm going to just start saying integral. We're going to take the integral of it, okay? So that will equal sine theta. You can look at your tables, and you say, okay, well, sine theta between pi and 0. Well, wait a sec. That's 0 minus 0. That doesn't make much sense. So what the heck? Well, I mean, you got to ask yourself, is this right? I mean, you always got to ask yourself after you do it, is this right? Because 0 doesn't make sense. I mean, I know there's area underneath cosine. Area of a circle is pi r squared. I mean, this is half of a circle. I mean, you should draw it first to see if it even makes sense to you. Let's do that real quick. We'll have this, we'll do this, and essentially a circle, a terribly drawn circle. So now, you have angle 0, you have angle pi, and you know that essentially cosine, it doesn't always equal 0 throughout all of these angles, right? You know that that's not true. So how does this work? Well, you have to realize that, sine doesn't equal 0 through all these, so you have to kind of just work it out. Well, what if I split it apart? What if we know it doesn't equal 0 here? We know sine of pi over 2 equals 1. So what if we changed pi over 0, or pi to 0, or 0 to pi rather, to, let's say, 2 times pi over 2 and 0. We could do the whole thing over again doing that, right? Well, let's see what happens, right? You get that, you get your answer, you get 2 times the whole function of sine theta between pi over 2 and 0, okay? That equals straight up 2 times 1 minus 0. Your actual solution is 2. Kind of interesting, huh? So you have to pay attention, make sure, especially when you're going into trig functions, that you don't get caught in some odd, like, trap. You don't want to say, oh, 0, yeah, 0 minus 0, that's 0. No, if you see something odd like that, you make sure that there's not just an in-between point, and that you're not looking at something especially symmetrical. You'll see that a lot in sine and cosine. So, I would recommend that you practice these problems more, but just keep looking out for little situations where you might find yourself missing a whole segment in between if you had to do an integral between A and B, or B and A, or whatnot. It doesn't matter. You have to make sure that you consider the in-between points. So just be cautious. And you guys have a good day, and keep practicing this stuff. You always get better. So I would start on indefinite integrals after this, once you feel comfortable here.